Space, the final frontier, and where we will be learning about multiplying and dividing radicals today. Yes, we're going to go on a journey into our rocket ship, and we will go and see how it all works together. And in the challenge section, be excited, we are going to do something that might remind you of English. Conjugate. Conjugation. Now, that might strike some fear in you, especially if you're learning French or Spanish or anything where you have to go and conjugate verbs. But don't worry, in math, it's just as much fun. So we'll be taking a look at that in the challenge section today. Let's get to it and blast off, dare I say. The wonderful world of radicals. We'll be looking at multiplying and dividing today. Let's take a look at what does the rule actually say. Let's use some letters to talk about the rule. I'm going to say a root b, don't get scared, times c root d. So what happens here? What actually happens when we're doing this? Well, basically, the numbers outside multiply together, and the numbers inside multiply together. So what would that give us? Well, that would give us an AC root BD. Okay, so that's what's actually happening. How about the opposite? Let's say we had A root B over C root D. So when we're dividing, what is really happening? Well, we're really saying this. A over C, so those two are dividing, and that's multiplying by kind of the root of B over D. Now, knowing that this is sort of the rules that are happening, then we can start to play around with some numbers. So that's the basic rules. Let's jump into some examples. Let's start off with a wonderful 2 root 3. I'm going to multiply that by a 5 root 2. So what did we say was going to happen? The 2 is going to go by the 5, and the root 3 by the root 2. And that will give us 10 square root 6. Okay, another one. Let's get going. Let's keep it rolling. Let's take a look, and I'm going to do tons of examples today. So lots of examples. Let's go 7 root 2 and multiply that by 3 root 6. So hopefully you can say, oh, that's going to be 21 root 12. Excellent. Moving on. Or are we? Well, no, you still need to remember that you need to go and simplify things. So you need to be thinking about what two numbers can multiply to give you 12, where one is a perfect square. And you're thinking that's going to be 4 and 3. And don't forget, you still have this 21 out here. That's multiplying. So let's go and do that. What's the square root of 4? That's going to be 2. So it's going to be 21 times 2. So that's going to give you 42 root 3. Let's see another one. Let's go with a kind of light blue color. And let's do 2 root 18 times 3 root 8. Now I chose this question because I think it is going to show a couple of things. Some kids might want to go straight to multiplying, which would be fine. But I like to go and simplify first. So I'm going to simplify this root, this 2 root 18 first. So I'm going to go and think of 9 and 2. And the square root of 9 is 3. So 3 times 2 is going to be 6. So I'll get 6 root 2. Maybe I'll just kind of make sure that this is very obvious what's happening. There we go. So 6 root 2. Over here, I'm going to do the exact same thing, and you're thinking 4 and 2. So 3 times 4 times 2. So 3 times 2 is going to be 6. And that's also going to be root 2. And now we're going to go and have that 6 times 6 and root 2 times root 2. We're actually squaring 6 root 2, aren't we? That's what we're really doing. So we would get 36 root 4. The square root of 4 is 2. So our answer is going to be 72. Pretty fun question. Let's keep the action going. So let's clear that out and get a fresh start. And where can we go with this? Let's say, what kind of question should we think of? Let's say we had, should we kick it up a crazy notch? Are you excited? Now let's start off nice and easy. So we're getting into some dividing. So 12 root 10 over 18. So I do want to go and show you how this will kind of work. And the 12 over 18 has to be simplifying here. So you simplify these numbers here like that, basically. So we're going to divide by 6. And you're going to get 2 root 3, and that root 10 is still up there like that. So nice little easy simplification like that. So just showing you some dividing. And let's keep going. Let's say we had a 4 root 15, and we would put it over a 2 root 3. So over a 2 root 3. So what's this really breaking down as? Let's use some colors. This is really saying 4 over 2 times root 15 over 3. That's what it's kind of saying. So 4 over 2, that's just going to be 2. And root 15 over root 3, that's going to be divided into 5. So that's going to be 2 root 5, just like that. There's some different ways to solve that one, but I think that's kind of the easiest way to kind of go about and looking at that one. Let's keep continuing onwards, and let's take a look at something that might pop up. This is more of a challenging sort of thing, but I do want to bring it up. So this is an important rule. And this rule is about rationalizing the denominator. And we'll talk about this in future videos. But basically the rule is you can't have a radical sign, a square root, in the denominator. So here we go. Let's just do 5 over root 2. Now, you're not allowed to have it. That's just basically the rule. You can't have a square root inside or in the denominator. So how do you get rid of it? Well, you're going to follow some math rules, and we're going to multiply the top and the bottom by the square root right there. So 5 times root 2. So 5 times root 2 would just be 5 root 2. Now I'll show this really slowly. So root 2 times root 2 is root 4, which the square root of 4 is 2. Now, if you take a look at what basically happens, so if you kind of put on your, what's my shortcut, is when you multiply 2 square roots that are the same, or if you square a square root, you basically get the number itself. So do realize you could go direct to 2. Okay, I personally would probably do that. So that's rationalizing denominator. So hopefully that gives you some good ideas about how to go and multiply. We're going to do one more, which would definitely be one of the more challenging questions, and it's going to involve FOIL. So we'll do this one for fun. So this is FOIL, first, outside, inside, last. So this is when you're multiplying binomials. So I'm going to show you this as the square root of 3 plus 5 squared. That means the square root of 3 plus 5 times the square root of 3 plus 5. Common kid mistake. So the KKM is the KKM. They just think this is square this. So it's like 3 plus 25. That's what a lot of kids think. So they think the answer is 28. So a lot of kids will just go and square this, and then they'll square this, and they'll combine it. That is not what we do. What do we actually go and do? Well, again, we're doing the square root of 3 plus 5 and we're multiplying it by itself. So the square root of 3 plus 5. And we're going to use FOIL, so that means the first things multiply together. Okay, you guys know how to do that. The second things multiply together. We also have the last things multiply. And which other ones have to go and multiply? The outside things have to multiply. So let's just go and do that. Let's work with it. What's root 3 times the square root of 3? Well, that would be the square root of 9. I'm going to go slow. You might want to put that as 3 right now. What would happen with the kind of green colored thing, the 5 times 5? Well, that's going to be 25. And then, of course, we have 5 times root 3, which is just 5 root 3. And we have also root 3 times 5. So there's going to be another 5 root 3. Okay. So now we need to go and simplify all of that. And you might have already done kind of the simplifying right here. So this is 3 plus 25. So this 3 plus 25 would give us 28. Now this part, we haven't talked about it, but adding radicals. So this is a 5 root 3 plus another 5 root 3. So how many root 3s are there? Well, it's 5 plus 5. So we'd say there is 10 root 3. It's not 10 root 6. Don't think that happens. Imagine the root 3 is so imagine that this is kind of like saying 5x plus 5x. So that's 10x. X just happens to be the square root of 3. So that would be our final answer, 28 plus 10 root 3. Well done. Good job. An excellent introduction into multiplying and dividing radicals with a little bit of FOIL and a little bit of adding and rationalizing the denominator. Good job, guys.
So for challenge, we are going to be looking at rationalizing the denominator in terms of radicals. So we're going to be looking at the conjugate and how that plays out and all the steps needed, and that will help you master the challenge section. Here we go.
Conjugation. When I first heard about conjugation in a math class, I thought, wait, this is math. And it made me go kind of like, no, this is bringing back bad memories of my French lessons back in Canada, trying to learn how to conjugate all those verbs. Necessary, but it was a little bit painful. So when I heard that we're going to be conjugating or using the conjugate in math, I kind of wondered, like, what are you talking about? So we're going to talk about how to rationalize the denominator. So a quick review is you basically can't have a radical in the denominator. So if you have something like the square root of 6 in there, you got to get rid of it. Okay, that's just basically the rule. And how we get rid of it is we multiply the top and the bottom by the square root of 6. And what that's going to do is give us 7 root 6 on the top. And then the bottom, root 6 times root 6 is root 36. And the square root of 36 is 6 itself. So this is like we're squaring this, basically. So I'm just going to write down a 6 like that. And that's our final answer. So that's called rationalizing the denominator. But what happens when there's more than one term inside the denominator? I'm glad you asked. That makes me happy. So let's go and take a look at that. So these are the questions that it's going to look like. Let's say we had 2 over 5 plus root 3. So there are 2 terms in here. And you just can't go and multiply by root 3. You can't do that because that will not get rid of the square roots. What you have to do is you have to multiply by the conjugate. Now, don't get scared. Here we go. You can all do this. The conjugate of something is, so if I had x plus y, the conjugate of x plus y is just x minus y. You're basically just saying to yourself, I'm going to keep the terms as they are, but I'm going to go and switch the signs. That's what you're doing. So if I wanted to go and do this, I'm going to multiply the top and the bottom
by 5 minus root 3 and 5 minus root 3. Okay, so that's what I'm going to be going and doing. Now, you're going to need to remember about FOIL because this is going to be really important. So let's just do an example of FOIL. Let's say you had 2x plus 3 times x plus 1. And you had to go and FOIL that. So you had to multiply the first, outside, inside, and last. Let's say you had to go and do that. And you go 2x times x, so that's 2x squared. 2x times 1 is 2x. 3 times an x is another 3x, and 3 times 1 is 3. Now, if you're a pretty cool student, you go and combine your like terms, combine your common x's, and you'd get 2x squared plus 5x plus 3. Okay, so that's when you're multiplying binomials and you're using FOIL. So we're going to use that idea for this. Unfortunately, we've kind of run out of space, so let's get a nice new sheet and set it back up again. So we had 2 over 5 plus root 3, and we're going to multiply by the conjugate, which is 5 minus root 3 and 5 minus root 3. Let's go and deal with the top part first. So that 2 would multiply by the 5 and the negative root 3. And we would get 10 minus 2 root 3. This is going to be a little bit tricky, but not too bad. There's a shortcut that we'll talk about, but let's just go and FOIL this. So remember, this is first, outside, kind of inside, and last. So if we go and do that, we would end up getting negative 5 root 3 right there. And then if we went and did the inside, we would get plus 25. We'd also get plus a 5 root 3. And then we would get a negative root 9. That's what we would end up getting. So let's go and simplify this. So our 5 root 3 and negative 5 root 3, they cancel each other out. And here, we just get 25 minus 3. So 25 minus 3. So we get 25 minus 3. So we would get, in the denominator, we would get 22. So over here, I'll just write 22. Are we finished? Is that our final answer? Well, there is something I like to call the golden triangle. And the golden triangle, maybe I should actually use the gold color. I think that's not too gold. Let's try and find a better gold color. This is okay. So this is like my golden triangle. So there it is. If the golden triangle has a common factor, and it must be a common factor in each point of the triangle. So here, here, and here. If they do, and in this case they do, they both have a common factor of 2, you can go and divide by that common factor. But if one of these things does not have a common factor, you cannot do it. So do keep that in mind. That's why I call it a golden triangle. So let's get rid of my triangle. And let's go and divide everything by 2. So I would left with 5 minus root 3. The root 3 stays the same, over 11. And that would be my final answer. Shall we take a look at one more? Why, okay, we certainly can. Let's take a look at 2 plus root 5. And I'll show you a shortcut for this one too. 4 minus root 5. So you already know that this is going to be one of those situations where you have to rationalize the denominator with a conjugate. So I'm going to multiply by 4 plus root 5
and 4 plus root 5, just like that. So if you really look at what's happening here, if you really take a look at it, there's a very interesting pattern. So what ends up happening? Well, you end up squaring the first term, don't you? Don't you end up squaring that? You sure do. So you end up getting 16 there. And then what ends up happening is you end up subtracting the square of the second term, so kind of minus 5. And your final answer is going to be 11. You're saying, well, what happens to like the 4 times root 5? Well, this is 4 times negative root 5. They're going to cancel each other out. So you're really dealing with the square of this. This is the shortcut, right? This is the square of this. And subtracting the square of this, which is itself. So that's the shortcut. If you can kind of remember that, that's super helpful. So our denominator is going to be 11. Over here, there's no shortcut. I can't help you. You just got to go first, outside, inside, and last. Okay, there's no way to get around that. Sorry. I love shortcuts, but there's none that I know of for this. So we're going to get 8, and then a 2 root 5, and then a 4 root 5, and then the square root of 25, which is 5. I know you guys know that. All over 11. So we got some simplifying here to do. I'm going to go and just change this just to 5, now that you've seen it, just to make my life easier. So 8 plus 5 is going to be 13, and I'm going to put I'll put the 13 there. How many root 5s do we have? Well, 2 plus 4, so 6 root 5. And it's all over 11. You want to do the golden triangle test. So golden triangle. So here's my golden triangle. Is there any common factors for 13, 6, and 11? Do they all have the same one? No, they don't. So let's get rid of that golden triangle. And is this going to be our final answer? Yes, it is. So there you go. So you've seen how to rationalize the denominators using the conjugate. Gosh, that sounds so impressive. Go and tell your friends and family what you just learned. Till next time.
Thank you for joining my journey together here in outer space. Hopefully you've learned something about multiplying and dividing radicals and how to rationalize the denominator. Until next time.